Hi, welcome to another tutorial, and this time we're going to talk about computer networks. So let's define computer networks. What is a computer network? It is a group of computer systems and computing hardware devices linked together over communication mediums to facilitate communication and resource sharing among a wide range of users. As you can see, you have at least two or more. The minimum is you have two devices which can be considered as computers which communicate with each other. So you can actually consider cell phones, from cell phone to computer or cell phone to cell phone. So that can already be considered as network. See, when there's communication between two devices, there's networking. So why is computer network required? And that's because, first of all, that is for sharing of devices such as printers, scanners, and etc. Aside from that is we can communicate data and information along with the applications and programs to intended users. We can ensure reliability through replication of data across systems as a proactive measure to system failures. And the bottom line is we share resources regardless of physical location, like what we're doing right now with our distance learning. We can still proceed with learning despite the distance. Okay, so we're actually taking advantage of the network. Now next is classification of networks. So there are several different types of computer networks. The computer networks can be characterized by their size, the communicating medium, as well as their purpose. The size of a network can be expressed by the geographic area they occupy and the number of computers that are part of the network. Networks can cover anything from a handful of devices within a single room to millions of devices spread across the entire globe. And networks geographically can be classified as LAN, MAN, and WAN. So that stands for Local Area Network, Metropolitan Area Network, and the Wide Area Network, or WAN. We can we'll take a look at some illustrations to show that the differences between LAN, MAN, and WAN. In terms of purpose, many networks can be considered general purpose, which means they are used for everything from sending files to a printer to accessing the internet. Some types of networks, however, serve a particular purpose. Some of the different networks, based on their main purpose, which are, the first one is it will serve as a storage area network, or SAN. Another one is it will serve as enterprise private network, or EPN, and virtual private network, or VPN. Now, this is what a LAN would look like. It is a computer network that interconnects computers within a limited, take note of the word limited areas such as residence, school, laboratory, university campus, or office building, and has its own network equipment and interconnects locally managed. Okay, so take note of this word limited area. So even if it's a big school that's within the area, limited area, say for example, Western Mindanao State University of Campus A and Campus B, that still is considered as local area network. And next one is leveled up, which is the MAN, or Metropolitan Area Network. is a network that interconnects users with computer resources in a geographic area or region larger than that covered by even a large local area network, but smaller than the area covered by the WAN or the wide area network. The term is applied to the interconnection of networks in a city into a single larger network, which may then also offer efficient connection to a wide area network. As you can see on the illustration, you have several LANs, okay, and then um, this LANs, take note, is in a limited area, okay, but with the metropolitan area, you're already considering a metropolitan from the word itself. Metropolitan, it's connecting the areas within the city or within the province. Okay, so that's metropolitan area network. And the largest one is the wide area network, which, as you can see on the figure, that it actually interconnects metropolitan areas of different sizes and from different places. Okay, so it's a telecommunications network or a computer network that extends over a large geographical distance and area. Typically, a WAN consists of two or more local area networks, and computers connected to the wide area network are often connected through public networks, such as the leased lines or satellites. Okay, the largest one in existence is the internet itself. Okay, so from the smallest to the biggest, so you have the LAN, next to it is the MAN, and finally is the WAN, the mother of all networks. So do you have any questions? Please post your questions and comments below, or you can ask during after this discussion. Next is components of a network. So as you can see, these are hardware devices. You have the router or the gateway, you have the switch, cable connectors, servers and clients, wireless access point or WAP, and the connectors, cable connectors, and of course the ones that are used by us, the end user devices, which are as you can see here. Let's zoom in. You have the laptop and the desktops and even cell phones, which are connected using Ethernet port, cable, Ethernet port connected to the Ethernet cable connected to the Ethernet port. So this is, we also call this as the network interface card. This is for the wired media, but for the wireless media, sometimes it looks like this, which has an antenna, and if you get the USB version, you don't have this, you won't need this anymore, the network interface card, just the USB device, and whose function is wireless networking. Okay, it will work as a wireless local area network adapter. So that's under components of a network. Next topic is the network topology, and it's the schematic description of the network arrangement connecting various nodes, the sender and the receiver, through a mode of connection. We have several of them. You have the ring, you have the mesh, star, fully connected, point-to-point, tree, bus. So just think of those nodes as computers, which are connected by lines. This can be logically or physically. Okay, so to make it more concrete, this is an example of a bus topology. So you have a line here, and then there are there's a terminator on both sides, and all the computers are connected in one line. It uses a trunk backbone to which all the computers on the network connect. And you have here the advantages and disadvantages. For the advantages, it's cheap and easy to implement, requires less cable, and does not use any specialized network. On the other hand, for disadvantages, if your network is designed in this way, network disruption when computers are added or removed because it's fixed. You have a one-line connection. A break in the cable will prevent all systems from accessing the network. And it's also difficult to troubleshoot. That's bus topology. Next one is the ring topology. As you can see, our computers are arranged in a ring design with the flow of the message in the same way. So the logical ring, meaning that data travels in a circular fashion from one computer to another on the network. And typically it's FDDI or SONET or token ring technology are used to implement a ring network. Ring networks are most commonly wired in a star configuration. So physically it would look like a star configuration, but how data is transmitted within the network is in a logical ring. There's a token that goes from one computer to another, which carries the packets. The advantages: cable faults are easily located, making troubleshooting easier. Ring networks are moderately easy to install. And the disadvantages are expansion to the network can cause network disruption. A single break in the cable can also disrupt the entire network. That's ring topology. Next is the star topology. As you can see, there's a central device in the middle that we call as a hub. All computers' devices connect to a central device called a hub or a switch. Each device requires a single cable, point-to-point connection between the device and the hub. And this is most widely implemented, and it's easy because it's easy to implement. So advantages: easily expanded without disruption to the network. Cable failure affects only the single user, and easy to troubleshoot and isolate. The advantages, on the other hand, requires more cable, and a central connecting device allows for a single point of failure, and more difficult to implement. Next is the mesh topology. As you can see, this is how a mesh would look like. This is a complete mesh. This is a partial mesh. That means for the complete mesh, each computer is actually connected with all the computers. Okay, so that's how a mesh looks like. Let's take a look at its details. Each computer connects to every other computer. High level of redundancy. So in the case that one connection fails, there are still other options for data to pass through. So advantages: provides redundant paths between the devices. The network can be expanded without disruption to current uses. For the disadvantages, it requires more cable, of course, than the other LAN topologies, and implementation is complicated. It's easy to look at it this way, but if your computers are actually located at farther and longer distances, that would really be very difficult to implement. And hybrid topology. It's a combination, from the term itself, it's hybrid. Okay, it is two different types of topologies, which is a mixture of two or more topologies. Okay, so advantages: it's reliable and effective as error detecting and troubleshooting is easy. scalable and flexible as size can be increased easily. For the disadvantages, it's obviously complex in design and expensive as a solution. It's hybrid technology. And those are the 5 topologies we have: bus, star, ring, mesh, and hybrid topology. Any questions? Feel free to ask those questions after the discussion. Next are the transmission media. These are what bring or carries the packets or data. So transmission media may be guided or unguided. So the guided are you have a physical connection, but with the unguided you only use the air, so it's wireless. Okay, so in the 7 OSI layers, the transmission media falls under the physical layer. From sender, it goes to the cable or air, and then receiver, which is also on the same level, which is the physical layer. This is the most famous transmission media we use because it's cheap, it's easy to also install. So it's UTP. It's actually twisted pair. So the U is unshielded, the S is shielded twisted pair. So depends on the material. So the shielded twisted pair, of course, is going to be more expensive than the unshielded twisted pair. But when it comes to screening and filtering noise, shielded twisted pair is better. So as you can see, the parts of it, you have the metal shield for the shielded twisted pair. For the unshielded twisted pair, you don't have that metal shielding. Next one is, okay, so we have categories of unshielded twisted pair. You have Cat 1, 2, 3, 4, 5, 5E, 6, 7. So for telephone lines, we just use the 1, Cat 1, and you can just check out these specifications. The ones that we usually use is Cat 5. Okay, so cable wire is normally 24 AWG with a jacket outside. So the rate of transfer is 100 Mbps. Okay, the ones that use a better category is the Cat 5e, which includes extra features to minimize crosstalk and electromagnetic interference. That means it's better protected from noise coming from other sources. So there is better reliability when it comes to transmission of data. So as you go down from one level to another, the data rate also increases, and so is the speed, and so is the price. The cost also goes up. Okay, so that's for UTP or unshielded twisted pair. So this is a UTP looks like, how it looks like. It comes in a lot of colors, but the colors actually signify durability or how it is actually used. Like for example, the yellow one, you use that indoor. The gray one also use that indoor. The blue one, the black one, you use that outdoor. Yeah, the outer insulators are thicker when they are used outdoor, and they are more prone to protected. I mean, they're more protected to twisting, folding. So that's why they are best used for outdoor. And then this is the UTP Pin Assignment for crossover. You have That's if you connect PC to PC and then you don't use a like a modem or a switch or a hub in between. You connect from PC to PC. You use the crossover configuration. So it's like it comes with a 1236 configuration where the 1 is connected to the 3 of the second of the other end. The 2 is connected to the 6 of the other end, and the 3 is connected to the 1 of the other end, and the 6 here is connected to the 2 of the other end. That's why it's called crossover cable. And that's what you use if you use the same. Usually, if it's the same kind of device, like PC to PC, okay, it's what you use, the crossover. And then for the normal, you use a PC to a hub, and then PC, you use the whatever is from one on the other side is the same as on the other side. So that's basically it. So this is the standard order of the color-coded wires. White, orange for pin 1. So that means on the other end, it's also going to be white, orange. Pin 2 is orange, so on the other end is also orange. So you just have to follow the same order from pin 1 with pin 2. Okay, so that's for a normal UTP cable. So that is connecting a PC to a hub or a switch. Now this is the shielded twisted pair. So you have outer protection plastic cover, you have a metal shield, and then inside that you have insulation and the copper inside. And this is another type of media. This is coaxial cable. This is what we use also for cable televisions, and it is thicker, okay, and it has terminators. It has special connectors like the one in RJ45 in UTPs. So this is what they use. So this is what a coaxial in detail would look like. So it comes with a 100 kilohertz and a 500 megahertz type. Okay, you have a plastic cover, insulator, outer conductor, and the inner conductor. Coaxial connectors. This is being used in computers. Usually we use this with a bus connection. Okay, so that's coaxial connectors or coaxial connection. So you have this is from the wire, and this is the receiving end. Okay, and the wire is with the male end, and then the female end is on the device itself. That is where you connect it. We call those connectors, by the way, as BNC connectors. It comes in forms like, for example, this one, you have a T connector, BNC T. So this is how you connect it. There's a cable from one end and the other to the other end, so you connect it this way. You have a T. Next one is the fastest one, the fastest type of media, and that is the fiber optic cable, because data travels in the form of light, and this is the most expensive material also. So fiber optic, jacket, cladding, and then the core. You have a plastic or a glass material in the middle. That is where the light passes through. So summary of characteristics of conductor media. So typical usage is data, video, audio, lens. The signaling technique is light pulses. Maximum data rate is 10 gigabits per second. Maximum range is 100 miles. That's why this is being used by the leading internet provider in the nation right now, which is of course PLDT, and they have been installing this. Despite of the distance, you still are assured of uh, the speed that it will still have faster speeds compared to copper, because data is transmitted using light. So this is how the detailed view of a fiber optic cable. So sender, receiver, and then data passes here through the core, bounces from one end to another. And these are the propagation modes: single mode, multi-mode. So you have step index and graded index. So the installation of fiber optic media is specialized. It cannot just be installed by untrained technicians or people who are going to install this type of material has to be trained, because they also use specialized tools, specialized gadgets to be able to connect these type of the fiber optic cables. And another thing, because it's made of glass or plastic, it can easily break if not properly handled. So that's it. That's for the transmission media. So that's all for it's like a short sort of review for networking. So we discussed about um, computer networks, classification of networks, why computer network is required, the types of uh, networks based on geographical area, which is landman and WAN. We also have discussed components of a network, which are the devices that connects um, the wires. Okay, we have examples of those are switches, routers, and we also discussed network topologies, physical and logical, and then finally are the transmission media. Okay, so that's about it for our lesson today. Thank you so much for listening and watching. If you have questions, just post your questions, and I'll be glad to answer it. Thank you for listening and watching. Have a nice day. Bye.